Hey people, what's up? Okay, so here's the deal. We found the most amazing mixture to keep you entertained in the most scientific way.
And that would be cornstarch.
Okay. So let me give you a quick background about what cornstarch originally is and what it's used for. It's used in cooking to make things like gravy. It's also used to...
Clowns use it in their makeup in order to keep their pores open.
And so it doesn't clog your pores and get like pimples and things like that. What else?
It's also applied to insect bites to make them stop itching.
Sweet. So, okay, so we're going to show you as a really strange thing, which is a characteristic of cornstarch. So solid and liquid? I don't think so.
Well, there's only one way to find out.
Test it. So, liquid or solid?
Well, as you guys can see, this is like a liquid, but it's a bit gooey.
It has soupy texture.
And
It's very thick.
As you like apply pressure, it becomes solid. As you can see here, if you punch it, it just becomes completely solidified. And if you
put your hands through it slowly, it becomes liquid.
So why is that?
Why is that? Well, it has a very good explanation actually. The cornstarch molecules, they trap water inside when pressure is applied. So you are able to do this and have, well, nothing, literally, on it. Okay? Whereas if you slowly place your hand in, there is no pressure applied, so the water is not trapped in it.
And therefore, you can extract your hands easily.
Okay. So, you might be thinking that this is a whole bunch of, whatever, like this might not be what it looks like. So here's what you do. You follow the scientific checklist. What is a scientific checklist? It's basically a bunch of rules of things you can do to make sure that what you're presented with is reliable. The first thing is observable. Can you observe it? Can you actually see that it becomes liquid? Yeah, there we go.
Punch it, it's a solid.
There we go. It's testable. Obviously, you can do this at home, and it's repeatable. If you get some cornstarch and add some water to it, you can also do this at home.
It's measurable and quantitative because
You can measure the viscosity of it during it when you have the pressure applied to it and when you don't. So you can actually see how much viscous it is.
And finally, it's without bias.
Yeah, definitely.
And, yeah, without bias, we're gonna have to use a volunteer for that.
Yeah.
We're gonna get a volunteer who knows absolutely nothing about this experiment, and we're gonna tell him what to do, and you guys see for yourself if it's gonna work or not. If it does work, then this is without bias. If it doesn't work, well, it clearly shows that we've included our bias.
Yes. Okay. So.
See you then.
Yeah.
Here's our volunteer, as we've promised. He's basically gonna demonstrate our experiment, and he's gonna do that by jumping on the cornstarch. If our hypothesis is correct, he's not gonna sink in. And this is supposed to prove that this is not biased because he does not know anything about what's going to happen. Go ahead. Yeah, good job. Well, this basically shows that we weren't biased, and that if you apply pressure on cornstarch, it becomes completely solidified. Bye. I think we're done here.
Yeah, I've had enough of cornstarch.
We'll see you next time with Boo Bubbles. Hey guys, welcome back. Okay, this is part 2 of our series, and we're going to be talking about Boo Bubbles today.
So what are bubbles?
Well, they're bubbles of soap filled in with carbon dioxide.
Okay, here we go. What does this look like to you?
Ice, bar of soap, maybe?
Okay, what is ice made out of?
Frozen water, I guess.
Okay, this is actually carbon dioxide. Okay, it's frozen
Now,
carbon
here's
dioxide.
the
Crazy thing about it is that you can't actually hold it in your hands because your hands will freeze. Okay? It's does anybody know the temperature?
Negative 110 degrees Celsius.
Oh my goodness. Okay.
Wow, that's...
So, yeah, so as we said, the crazy thing is that now it's a solid, and as you can see, it just goes off to
a gas.
gas. And that is called sublimation. Okay? So, here we go. We're gonna make some Boo Bubbles!
So here's the scientific explanation of why the boo bubbles burst when they touch the human hand.
All you need is some milk, colors, and soap. That's it. Okay, so first you apply the colors. Let's take some green, put it in the milk. Put some red in here. A little bit more. Okay. Blue?
Yeah.
Yep. as you can see, the colors are kind of together. And we take a little bit of soap. This is normal soap. You basically just dip it in there. You see? Whoa! Whoa!
This is cool. So here's the difference between milk and water. When we put some colors, like we're gonna try some blue over here, and basically dip it into the water. Yeah, wait, please hold on. Okay, there's some blue in there. When we add soap, the blue won't disperse just like what happened in milk. So let's see.
Doesn't move. It moves a little bit, but not a lot. You can't even. So here's how the soap actually works. It has two parts: a hydrophobic and hydrophilic part. Hydrophobic meaning that it is water-hating, and hydrophilic meaning it is water-loving.
So this means that the hydrophobic runs away from water and goes into fat and tries to attach itself into fat molecules. And the vice versa for the hydrophilic. It runs away from fat and attaches itself to water molecules.
Therefore, the best soap has more hydrophilic parts because there's like kind of a struggle that goes on, and so the hydrophilic part is still attached to the hydrophobic part, and it pulls it away from the actual thing, which is, you know, like if you have ever grease or whatever on your shirt and you wash it, the hydrophilic and hydrophobic have a struggle, and it is pulled off through the hydrophilic part.
Yeah.
Phobic, philic. Oh, this is getting too confusing. Yeah. So basically, that's how it works.
Ooh. Let's see if we can get any blue bubbles going on.